Hey, good morning. Just give it a couple more minutes
Okay.
until more people join. But yeah, thanks for joining. All right. So looks like we might have a short meeting today, or not that many people join, or maybe just the two of us.
And no worry.
Yeah.
We can keep this simple.
Yeah, we can get started. I mean, this presentation is actually recorded,
Yeah.
so I'll post it on the YouTube channel.
Yeah, of course. Sure.
Yeah, and then get started. You can
So
go
let's
ahead.
get okay.
Get started.
May I share the screen?
Yep.
Is it visible?
Yeah.
Ah, good. Oh. Um, so hi guys, this is the issue. So actually, just two of us. No worries. And I'm very glad to be here to introduce clusternet, and which is a pretty new project. This is my GitHub handler, also my Slack ID. So please don't hesitate to interrupt me if you got any questions during my talk. And Kubernetes is becoming ubiquitous and fundamental, as you all know it. It is going under the hood similar to Linux. The goal of clusternet is to have manage your clusters, quite a few Kubernetes clusters. The clusters could be running in public cloud, private cloud, or hybrid cloud, or even at the edge. Also, clusternet can help deploy and coordinate applications to multiple clusters from a single set of API in the hosting cluster. Actually, the name of clusternet comes from a combination word of cluster internet. Just as the name says, it will try to help manage your clusters as if they were running locally. And this also help eliminate the need to jungle different management tools for each cluster. Actually, we started the project last year, about March, and we open source the first release at June, just 3 months later. You can check out this GitHub URL. Actually, we have released 7 releases until now, and the latest release is coming soon. So it will be at the end of February. Also, we have submit CNCF sample project, and it is being reviewed. clusternet is designed to be multi-platform supported, so you can join clusternet in any Linux distros. So this is just a brief history of clusternet. Actually, it is quite new, and it is less 1 year. So, and the clusternet is add-on that help to manage all your clusters. Actually, before we build this project, we have looked through all the cloud native community and found out if there is a project that can best meet our needs. So, but unfortunately, there is no one that we can use. So we just build this project, and I found this project, and fortunately we made it out, and we start to contribute this project to the cloud native community. And actually, the main parts of ClassNet is focused on cluster management and application management. So you can just see the two items in the box here. Also, we are also focused on multi-cluster scheduling, and we have provides configuration overrides. And in the later diagram, I will show how ClassNet handles this. And ClassNet is designed to be add-on, so it is easy to use, and it is easy to integrate. So we also build out a plugin for Kubectl, so you can just use Kubectl to interact with ClassNet as well. So we also build out a Cango wrapper, so it will be pretty easy to integrate in your existing systems. There is very little effort to migrate from your single cluster controller to multiple cluster controller. So it is pretty easy, and you can check it out on our GitHub README. And this is architecture of ClassNet. So ClassNet consists of 3 components. So one is ClassNet agent, ClassNet hub, and ClassNet scheduler. Just as you see, the ClassNet agent runs on every child cluster. And in this diagram, we have 2 concepts. One is parent cluster and one is child cluster. Just as the name says, the child cluster will address itself to the parent cluster, and the parent cluster will be the main control plane to manage all your clusters. And the fascinating part of this is ClassNet can reject itself to reject itself as a child cluster. That means you can manage your parent cluster as child cluster. So I think this is the most fascinating part of ClassNet. And I don't see any other projects has this ability. The agent running in every child cluster will be responsible for readjusting itself to the parent cluster. Also, it will try to help build up or set up a long WebSocket to long connectivity to keep the heartbeat of ClassNet of child cluster and with parent cluster. And the design of this piece, as you know, the child cluster will be running at any places, such as on the edge devices or sits behind the firewall. So if we try to connect with the child cluster, we need to find out a way to break the network connectivity. But actually, the network will not expose any valuable endpoints. So we just reuse the connection from the child cluster to parent cluster. And this is another fascinating part of ClassNet. So this will help to eliminate all kinds of heterogeneous environments to connect your clusters at any places. And the ClassNet agent will also help to report the heartbeats of child cluster, the cluster credentials, and the cluster metadata to the parent cluster. And the parent cluster, the ClassNet hub running in the parent cluster is responsible to approve all the cluster registration and also help to auto-populate all the needed credentials for the child cluster. Also, we have a ClassNet scheduler here. So the scheduler here is pretty simple. It is to help coordinate all the applications to different clusters, which are based on cluster selectors, cluster tense and tolerations, etc., etc. So this is a very simple architectural ClassNet. It is trying to be simple, but full-fledged and powerful features. So users can just build on ClassNet to better manage our clusters. And for the application management part, we have designed such a diagram. You can see the blocks with two colors, a green one, and a purple one. The green ones are user-created objects, and the purple ones are ClassNet auto-populated objects. We have ClassNet can help to distribute all kinds of workloads, such as Helm chart deployments. This is Kubernetes built-in workloads and CRDs. So if you want to distribute your application to multiple clusters, you just need to define an object that called subscription. And in subscription, we have defined several fields such as subscribers and feeds. Just as you know, these two concepts are just borrowed from the well-known RSS. So it is pretty to know the exact usage, and the users get familiar with this concept. And in the subscription phase, all the objects are referred by their kind and name. So you just need to put your kinds, such as Helm chart, the Helm chart name, or the namespace. This is defined as a field, and you can combine multiple fields into subscription. So that means that you want to deploy a batch or bundle of resources into a cluster or into multiple clusters, and we call this is application. Application is usually consists of multiple resources. So this can help to define application. And the subscribers here is to indicate the cluster you want to distribute to. And currently, ClassNet only support level selector of clusters and cluster terms and tolerations. And we are trying to introduce more scaling strategies in the next few releases. So is the server, I mean the ClassNet hub. The ClassNet hub will try to distribute this subscription to targeted matched clusters, such as just as the diagram shows. We have two subscribers here, cluster 1, cluster 2. So the ClassNet will try to break this subscription into two objects called base. And each base is running in cluster dedicated namespaces. Acting ClassNet for every rejected cluster. ClassNet will distribute a dedicated namespace for that cluster. So then all the objects in that namespace consist of the deployments or descriptions for that cluster. So this is quite straightforward. And after populating base, we can apply overrides here. So we are trying to, we have designed the two-stage priority-based overrides policy and globalization and localization. Actually, either of them can help do the overrides here, but we just split them into two. The reason is we can, in some cases, globalization is more useful. On the other hand, localization is preferred, such as when you try to override only a cluster for one cluster, so it is just straightforward to define a localization for the cluster. Oh, let me get it straight. The localization is a cluster scoped resource. So it is for all clusters. So all clusters can use this same object. And in globalization, we have defined the cluster lab selector. So actually, globalization can match a set of clusters or all clusters. So it is based on your definition. And the localization is the namespace of the resource. So it resides in dedicated cluster namespace. So it is only used by that specific cluster, such as cluster 1 and cluster 2. And both localization and globalization has set a priority. We have introduced priority to support more complicated scenarios, such as you want to roll back a configuration and for one cluster, but you don't want to influence other clusters. So you can just create a localization for the specific cluster. After all the overrides is being rendered, a new object will be created called description. And the description is actually the final raw manifest that can be deployed to the child cluster. So it is the final results or rendered results, including all the overrides. Actually, it is a little bit complicated, but if you try out our demo on GitHub, so you can find the code to make it clear. So, and I'm going to demonstrate how clusternet to two parts. About one is about cluster management, and the other is application. Let me show the demo. Here's the demo, and I actually have created two clusters running in cloud. So just as to split the window here, the left one will be used as a hub cluster, and the right one will be used as a child cluster. So I have a script for demo. So actually, this is pre-defined environment, so just skip the completed bootstrapping. And here is a good config. So we call it cluster 2. And okay, so to the bottom of the window. And let's check out the server. The server is really the internal address. So let's ping the address. Yeah, the server is alive. And now we are going to get the namespace. Cool. And we try to create a namespace called TAG-Runtime demo agent. Yeah, it is running as expected. And I will deploy a cluster agent in this cluster. So let's check out. Yeah, the agent is running, but we switch back to the parent cluster, the left one.
So question, do you have multiple agents because is that a daemon set or what is that? Like for every Kubernetes node, there's an agent or?
Yeah, for every cluster, we will install a cluster agent. The cluster agent will have to redress the current cluster to the parent cluster. But in the right, this one, yeah, I have set a wrong configuration, so the agent will always fail to redress itself to a parent cluster. So I will demonstrate it afterwards.
Got it.
Yeah, actually to cluster in the cloud, but in different PCs. Yeah, it is different from here, right? Yeah. And the pin itself, it is working. Now it's not working. Great. And trying to get namespaces and create a namespace TAG-Runtime demo hub. And we try to differentiate the two clusters. So we have different namespace name. You can get namespaces. Yeah, great. But if we are trying to visit child class 2 from class 1, it's not working. So this is because class 2 is residents in different VPCs, so the network is not working. Yeah, the clusternet hub is running as expected in child class in cluster 1, and this will be used as a parent cluster. Let's check out the registration request. When the agent starts, it will try to create a cluster registration request to the parent cluster, and the parent cluster will receive the request just like you're registering a node to the API server. The kubelet will try to send out a CSR to the API server, and the API server will approve the CSR. The same method for clustering. They will try to the cluster agent will try to send out cluster registration request to the hub, and the hub will try to approve the registration. Actually, you can find out there is no cluster registration request here. It's because I didn't have the right configuration for the cluster agent. That means the cluster agent is connecting to a wrong hub. So it will try to keep trying to insert to the parent cluster. Let's check out the log here. It says that, yeah, it says that you try to create a cluster registration request but failed. Now let's give a right address here. Actually, the clusternet agent is running as a pod, and I have ingested a secret to the pod. So all the container in the pod is run with the environment injected by the secret. So I just need to edit the secret here and restart the pod. Then it will be used the correct parent URL. Yep. And this is a correct URL here. So I just apply the secret, and now we need to rescale the pod with the new configurations. Before that, we can have a watch on cluster request here. Yep. Now we recreate the pods, scale down and scale up. Yeah, correct. Good. we can see that the class registration is created and proved. So, and let's see what happened next. The clusternet hub, after approving the request, the hub will try to create a dedicated namespace for this cluster. So we can see that a new namespace is created here, is prefixed with clusternet. And the manager cluster object is created as well. So you can check out the child cluster with versions with 1.20, and it is ready and it is just created. So this is a successful cluster registration request. And after this, we can check out the manager cluster. The agent will try to report the heartbeat of current cluster, and also some metadata, latest version here, and the node status ready nodes here, and the platform, etc. Also, CRDI is reported as well. So it is also demonstrated that the child cluster is trying to set up a WebSocket connection, such as use socket is set to true. This indicates that the agent is setting up a WebSocket to the hub. So we can just reconnect reconnect back to the child cluster with this long connected connection WebSocket. Right? Yeah. So this is about the cluster registration. After the cluster registration, we can see that a unique cluster ID is distributed for every cluster. So this is a cluster ID, and you will trying to connect to the child cluster. You can just copy this cluster ID and we can try to use cluster Kubectl plugin. This Kubectl plugin is already been integrated by crew. You can just search clusternet. Yep, it is installed here, and we now can use this plugin to get namespace. Could be configured here is cluster one. And we also need to pass the child could be config. Actually, the child could be config is internal address here. So we just do not need to export the accessible ID. Yep. Oops. Oh. Oh, seems to be wrong. Oh, actually, if we can use the correct credential here, we can connect to the child cluster one, child cluster here, and we can get all the namespaces here. If the demo is not as expected. And this is the demo here. And for the application coordination, you can just check out the doc on our GitHub. And these are some notable features of clusternet. Actually, clusternet focused on cluster management and applications. So you can just deploy all kinds of resources, including Helm chart, CRDs, and Kubernetes building resources to match the clusters. And we also provides two-stage priority-based override strategies. So it will be easy to look back and do cross-cluster canary routes. And with clusternet, you can just you can very easily to register and manage any Kubernetes clusters and any Kubernetes that are certificated by the conformance test. They can clusternet can help to manage them all, and you can just use the full-fledged RBAC everywhere. This is just the demo here. So, but it seems the credential is correct as we expected. We'll find out later. And in this is the afterwards roadmap of clusternet. And clusternet in the next few releases, we're trying to provide more pluggable cross-cluster scaling policies, and also focusing on the mesh spot and monitoring logging, and also cross-cluster horizon pod autoscaler will be addressed as well. It's because there are lots of scenarios that are focused on rebalancing the pods from the different clusters. When the cluster is down or the cluster capacity is there is no more resources for the cluster. And also we want to integrate the current open source projects that focus on data plans. So that's such as Submariner. It will help to coordinate. It will help to flatten all the cluster networks between different clusters. So this is a future roadmap of cluster, and thanks for listening. And if you've got any questions, feel free to ping me on Slack. This is my Slack ID. Yeah. Any questions?
Sounds good. I don't have any questions. I mean, it's just like it's a little bit more about just trying it out.
Okay. Yeah, that's a little failure in the demonstration here, so I'll just figure out later. And yeah.
Oh, I guess one question. So, who are the current users for the project or end users?
Yeah, actually, we lots of users are trying to use in cluster to have manage their cluster running at the edge, such as a Raspberry Pi. And also there are some customers that are using cluster to manage their clusters that are running in their own RDC servers. But these RDC servers are not exposed to any connectivity. So with cluster, they can just reuse. They can just set up a cluster control plane in the public cloud and running a cluster agent in their RDC servers. And so the cloud and the control plane in the cloud can manage the clusters running in the RDC servers. So this will help to eliminate the resources to set up a specific network that connects from the cloud to the RDC servers. And also there are lots of platforms that are trying to build in distributed cloud platforms. So they can just rely on cluster to help to set up the control plane and managing all their clusters.
Got it. Another question is, can you actually manage clusters among multiple cloud providers? So
Yeah.
you have EKS or GKE and
yeah.
so
yeah.
So you support the API, their APIs too as well, right?
No, actually, we don't support any SDKs from cloud providers. Actually, Kubernetes has done everything for us. We just reuse the Kubernetes API to help us to eliminate the different differentiations of different cloud providers. So
got it. Yeah. So
yeah.
like the the cluster have like the cloud controller. Then
Yeah.
for example, like they would actually create the load balancers for that specific cloud provider, right? So and then you just kind of reuse those, right?
Yeah, exactly. And we can just reuse the CRD to define our own logics, and then we can install several operators or controllers to watch the CRDs, and all the flow is connected. Yeah.
Awesome. Well, thank you.
Thank you,
This was
guys.
great, and I learned quite a bit about the project. So looking forward to seeing it mature and through some of the stages in the CNCF. I think it's already in Sandbox or being reviewed for Sandbox, right? So.
Yeah, thank you. It's in the review process. It will be in the early March.
Got it.
Yeah.
Got it. That's good. Well, thank you. Have a great day.
Have a great day. Thank you, guys. Bye-bye.
Bye.